Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on EMC consideration. Okay, so for this video, I'm going to discuss on the practical aspect on radiated emission, okay, which is also known as RE. Okay, so this video, I'm going to do a demo. How can we actually execute this radiated emission test based on IEC EN 61000-6-3 standard, or you also know as CISPR 11. Okay, so basically for this video, I'm actually test the DUT against CISPR 11 standard. Okay, so we also have CISPR 32. As for US, we have this FCC Part 15 series. So this objective of this video is to discuss on the practical aspect. Okay, so step-by-step demo, how can we actually perform radiated emission measurement? This will be the Part 57 series discussion on EMC consideration. So guys, if you're keen to know more about EMC consideration, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on EMC. This is my email. If you have any question regards on this discussion, please drop me an email. Or if not, I actually prefer you guys to send me your question through the comment. Okay, so this is because I hardly check this email. So guys, if you want to have a faster response, okay, please ask the question through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Okay, so let's continue. Okay, before I show the video on the practical aspect on the radiated emission test and measurement, okay, I just want to quickly highlight some of the key so-called setup that we need to have. Okay, so basically this diagram is actually inside a EMC chamber. Okay, so basically this is a fully enclosure, EMC enclosure, you can imagine that. So the key thing that I'm going to discuss will be the IEC EN 61000-6-3 standard. Okay, so whatever CISPR standard 11, 32, etc., they were compliant to this, except CISPR 25. Okay, for CISPR 25, the distance between the turntable and the antenna is 1 meter, and the height typically they have some constraint on the testing. Okay, but whatever that we discuss over here or the demo that you're going to take a look, basically fall under CISPR 11 standard. So under this CISPR 11 standard, okay, the distance between the turntable, okay, to the antenna or the DUT against the antenna, okay, they can be either 3 meter or 10 meter away. As for the height of antenna testing, okay, typically, okay, for fully compliant will be for 1 meter up to 4 meter. Okay, but over this chamber that I'm going to demo to you, okay, it is a so-called pre-compliant. So they are only able to test 1 meter, and then another one will be until 1.5 meter. Okay, so therefore, because of this become a pre-compliant chamber. And then another item that we have will be the rotating table, as you can see from here. Okay, so the rotating table actually just will rotate to ensure that all facing of the DUT will have the opportunity to face at least once to the antenna. Okay, so next, this is a clearer picture. Okay, so this is what I have described earlier on the inside the chamber. So this will be the turntable. Your DUT will be turning around. So they can be either 3 meter, okay, or 10 meter. Okay, for this demonstration, it will be just 3 meter. So the antenna is actually hooked up to a spectrum analyzer. Okay, so if you realize later on, you will realize that we actually have, besides spectrum analyzer, we also have a EMI receiver. So in short, they were switching between spectrum analyzer and EMI receiver to capture the DUT emission. Okay, so basically, in short, we need to have this form spectrum analyzer or EMI receiver, okay, to measure the electromagnetic wave that is released by the DUT. And then all these spectrum analyzer, EMI receiver, they are actually send the data to a computer to do some analytics. So basically, based on the analytics, they will give a conclusion, okay, whether the DUT pass or fail the test. Okay, so let's go over to the demo of the radiated emission test and measurement. Thank you. Okay, so these are all the tests and measurement that are required for EMC. Okay, so you can see that on your left, okay, so this step here is mainly to use radiate emission. Okay, so over here you can see that we have spectrum analyzer and also EMI receiver. While on the other side is mainly to use for radiate immunity. So right on top of here will be a signal generator. So these are all the series of amplifier to boost up the signal large enough to work as radiate immunity. Okay, so as mentioned earlier on, okay, so this step is mainly used to measure radiate emission. Okay, so right on top of this is basically to control the turntable. So basically this will control the turntable to turn from 0 to 360 degrees. Okay, so next, this will be a spectrum analyzer. Okay, so spectrum analyzer is initially used at the pitch search. Okay, so basically after they perform the pitch search, they actually will go to EMI receiver. Okay, so this will have some detailed analysis of the data to see whether if they compliant to the EMC standard or not. Okay, so next over here will be the selector switch. Okay, so in short, this selector switch will select either the spectrum analyzer or the EMI receiver. Okay, so based on the different need, it will actually switch it, okay, based on the criteria, whether is it at spectrum analyzer or EMI receiver. And last but not least over here, this is mainly to control the antenna mast. So the height of the antenna mast is actually controlled over here. Okay, so this type of equipment is mainly to use for radiate immunity test and measurement. Okay, so right on top of here, this is actually a signal generator. Okay, so basically the source of the electromagnetic wave is basically generated at this part here. Okay, they basically will generate the source of the electromagnetic wave that will be used to so-called as the interference to the device under test. Okay, so over here you actually can see that there are a series of amplifier. Okay, why we need to have so many amplifier is because they cannot be have one amplifier that can work from all the way from a very low frequency all the way to the high frequency. So in short, okay, basically this amplifier work hand in hand. So for example, this actually belongs to the lower frequency, okay, and this belongs to the higher frequency. So basically with the combination of low frequency, this amplifier will be on, okay, to produce the electromagnetic wave to meet the volt per meter, and then after that, let's say they move to a higher frequency, the other set of amplifier will be turned on to provide the volt per meter to meet the criteria of the radiate immunity test. Okay, let's come to the antenna mask. Okay, so this is the antenna mask. So for RE, the antenna mask need to work from 1 meter to 4 meter. Okay, however, because of the constraint of the height of this chamber, okay, we can only test at 1 meter and 1.5 meter. Okay, but over here you can see that just now the antenna hoists up from 1 meter to 1.5 meter. So now they actually change from horizontal polarization to vertical polarization. So in short, the antenna will be hoisted up, okay, to do a pitch search. Okay, start off from 1 meter. After they complete all the pitch search at all the frequency, they will move up to 1.5 meter. Again, they will do all the pitch search. Then they will move up to 2 meter, and they will do up all the pitch search. And let's say, okay, if this chamber is 4 meter, then it will go from 1, 1.5, 2, 2.5, 3, 3.5, 4 meter, and finally all the result will be captured. Okay, so now let's come to the turntable. Okay, so over here you can see that this is actually the turntable. Okay, so on the turntable you can see that we actually has so-called label 0, 90, 180 and 270. So typically for RE, the DUT need to be placed at the center of the turntable. Okay, so this is because just imagine if the DUT is on either one of the edge, so there will be a potential that they will be further away from the antenna. Okay, therefore for RE, okay, the DUT need to be at the center of turntable so as to ensure that at all time they are 3 meters away from the antenna mast. Okay, so on the turntable you probably can see that there is a lot of boxes, so-called, they are actually separate by 10 centimeters. So in short, whatever so-called auxiliary that you want to do, you need to place them at least 10 centimeters away from your DUT. Okay, so basically this is the key purpose of this all these boxes. So basically, as I mentioned, okay, any form of auxiliary that you need to support your DUT testing, okay, they need to be at least one box which is 10 cm away from your DUT. Okay, we are using the software by Toyo. Okay, so basically this is a configuration for radiate emission. So firstly, you can see that this red line is what we call the limit line. Okay, so for this case here, we activate the CISPR 11 testing. So basically, in short, this red line represents the CISPR 11 limit line. So when we actually do the test later on, okay, you will see a lot of spike. So the spike may exceed the limit line, some may be below the limit line. So whatever that is above the limit line, we will send it to do the final test, okay, which you can see from here. For those that are below the limit line, which means that they actually meet the criteria. So in short, in order to meet the full CISPR 11 standard, we need to ensure all the points are all below the limit line. Then therefore we can declare that this DUT actually passed the CISPR 11 test. Okay, so we are going to take a look on the spectrum analyzer view. Okay, so we are going to take a look on the view of spectrum analyzer. Okay, so for this RE, okay, we actually break into two frequency band to test. So this is the lower frequency, which means that 30 megahertz, and the upper range will be 1 gigahertz. So what they are going to do is now, okay, the turntable will turn to 0 degree and the antenna will be at 1 meter. So after all these are all in place, then they will set the frequency as mentioned, 30 megahertz and 1 gigahertz. Then they will do the max hold and then they will hold on to the peak surge. So basically from there they actually so-called capture all the reading that actually from 30 megahertz to 1 gigahertz. So now you see that they are all ready. So now you can see that they are actually doing the max hold peak surge, okay, from 30 megahertz to 1 gigahertz, and the turntable will turn, okay, from 0 degree all the way to 360 degree, and the antenna will remain so-called fixed at 1 meter to capture all the emission that is released by the DUT. Okay, so we have finished the horizontal testing at 1 meter. So from this diagram here, you can see that all of them actually meet the so-called spec because they are all well below the CISPR 11 standard. So basically this is actually what is the emission released by the DUT. Okay, as you can see from here, 30 megahertz all the way to 1 gigahertz, and at all the different phasing from 0 all the way to 360 degree. So this will be the emission from the DUT for horizontal polarization. Okay, so now we are going to do the vertical polarization. So basically now the antenna will change from horizontal to vertical polarization. So after that, again, they will repeat what we have shown you earlier on, which is from 30 megahertz to 1 gigahertz. They will do a max hold, as you can see from here, and then they will do all the peak surge. So this is actually all the DUT emission, okay, for the vertical polarization at 1 meter. So earlier on, we will show that it's actually on the horizontal polarization, and then 1 meter they capture all this, and then after that they go to 1.5 meter, they capture all this. Okay, in the real scenario, if let's say this chamber is 4 meter, so this thing will go on all the way until 4 meter. After that, they will switch to vertical polarization, and then again they will do all this. So basically, in short, this is actually the so-called emission from the DUT, okay, for vertical polarization from 30 megahertz to 1 gigahertz. Okay, we have finished, okay, all the peak surge, max hold peak surge tasks over here. So in this diagram, you can actually see two set of graph. Okay, so the blue one is actually the horizontal, as you can see from here. Okay, so basically this is actually from the horizontal polarization. Okay, so this is the emission that we capture from 1 meter, okay, 2 meter, 1 meter, 1.5 meter. Let's say if this chamber is 4 meter, so it will be a combination, okay, all the max hold from 1 meter, 1.5 meter, 2 meter, 2.5 meter, 3 meter, 3.5 meter, and 4 meter at the horizontal polarization. Okay, so next you can see the so-called purple line. So basically for the purple line is mainly for the vertical polarization, as you can see from here. So they are the same. So basically if let's say this chamber is up to 4 meter, so this is basically the maximum value that is released for the vertical polarization, okay, for 30 megahertz all the way to 1 gigahertz from the height of, again, will be 1 meter, 1.5, and then they will also do 2 meter, 2.5, 3 meter, 3.5, and 4 meter height. So basically this will be so-called show you the two set of results, okay, for horizontal polarization and also vertical polarization for all the various respective height. Okay, we have finished all the max hole, okay, and then pit search. So now we are going to generate the suspect list. Okay, so over here we have do a setting, okay, for anything that is within the 6 dB within the limit line. Okay, for example, this point, okay, most likely they will be so-called under the suspect list. Okay, we are going to do a final evaluation, as you can see from here. So basically, before we actually come into the final evaluation, okay, we are going to select the point that is so-called within 6 dB on the limit line. So basically, all these frequency point, okay, will be at the suspect list. And now you can see that I mouse it over the suspect list, and I ask them to generate the suspect list. And from here, you can see that these are all the frequency point that is so-called within 6 dB of the limit line. So from here, let me show you in more. So basically from here, you can see that there are actually 4 points that we need to send to do the final evaluation. Okay, so now we are ready to do the final evaluation, okay, which is here. So I need to mouse over here, and I actually will execute the final evaluation. When I actually do this final evaluation, okay, so the EMI receiver will do the final evaluation rather than the spectrum analyzer. So let me just click, okay, so basically you can see that they actually will do all the initiation now. Okay, so now we are doing the final evaluation. So earlier on, you can see that on the first point on the suspect list is actually 30 point something megahertz. So basically, okay, the first form of test will be at spectrum analyzer. So you can see that the spectrum analyzer, okay, will focus on the frequency on around 30 megahertz. And what happened here is basically you can see that the turntable will start to turn. So in short, they are actually looking at the phasing that can have the worst scenario, that have the maximum release from the DUT, okay, at the different phasing of the turntable. Okay, the antenna mask will also slowly move, okay, to find out that at what height, okay, the DUT will have the highest emission. So in short, you can see over here, okay, the spectrum analyzer work together with the EMI receiver. Okay, so now the spectrum analyzer will not do any form of measurement. So now all the form of measurement will be done by the EMI receiver. Okay, so basically you can see that instead of about 30 megahertz, they actually found out that the maximum frequency that release this emission is around at 26.67, and you can see that we are actually doing the average. So basically they are going to do the average point, and then from here they will determine whether the DUT pass or fail the test. So basically in short, you can see that the final evaluation is done by two set of equipment. Okay, firstly they were done by the spectrum analyzer. Okay, so after they have confirmed the frequency of band, they're having this form of error, they actually will switch over to EMI receiver to do the scanning. And for this configuration, for this CISPR 11, okay, they actually will do the average. So from here you can see that they will take up all the average value, and then later on we can take a look on the computer to see whether they pass or fail the test. Okay, so the final evaluation test is up here. Okay, so besides doing the average, they also will do the quasi-peak. Okay, so just now, as I mentioned, that the frequency that fail is actually will be at 26.674 megahertz. So the worst phasing, as you can see from here, the worst phasing will be at an angle of 189.1 degrees. So basically with this phasing, it pick up the most emission from the DUT, and also at the height at 117. So in short, at this case, this is actually the worst scenario that pick up from the DUT, okay, at this frequency. Okay, in short, the height will be at 117 cm, okay, which means that it's about 1.1 meter, and the angle at 189.1. Okay, so basically over here, this actually draw a conclusion. Okay, so what will be the margin? Okay, so over here you can see that this actually failed the test.
Okay, so you can see that they fail at minus 48.5. So which means that this duty actually does not pass the EMC test and measurement. Okay, they fail at this level. Okay, and then the rest of the thing you can see that they are all here. So basically these are all the value that they capture, okay, which is 48.5, and they actually generate this so-called margin. Okay, so in short, okay, they actually fail the test of this EMC test and measurement. So in short, okay, I can conclude that this laptop doesn't really meet the criteria of CISPR 11. Okay, they fail this test at around 26.67, okay, at the margin of this. But over here, why I would say that it's very subjective that this product will still meet the test is because for radiated emission, the test actually started at 30 megahertz. So I suspect that the manufacturer of this actually conclude that at this frequency is not part of the radiated emission test. Okay, but over here you have some form of idea how does the radiated emission test is done. So, but because the frequency is actually so-called lower than the criteria is 30 megahertz to 6 gigahertz, but over here is much lower than 30 megahertz. So therefore, because of this, I guess that probability that the manufacturer of the laptop actually certified it passed the test, because this is actually well below the frequency of test for RE. So in short, I think that's all. Hopefully you have a better idea how this RE task is done. Thank you so much.